students, AsswalaMualaimum. I'm Rabeya. Welcome everyone to my secondary channel that is known as higher mathematics. However, in the discussion of part 1, we also knew about what is set and various types of sets such as universal set, subset, power set, infinite set, finite set, complement set, etc. After that, in the discussion of part 2, from sets and function, we knew about the listing method and building method of sets, which are known as roster method and rule method respectively. And in the finishing of part 2, we solved some mathematics from the example of chapter 1, which were related with the roster method and rule method. So students, now you can guess my today's video is actually part 3 of sets and functions. And in my today's video, we will solve together first activity completely from the example of first chapter from your higher mathematics book. After that, we will know about Venn diagram elaborately with its figure. So students, let's get started our today's video. Now we will solve completely first activity from sets and functions. Then we will practice 2 or 3 maths like the first activity maths. As you know, in the video of part 2, we solved number 1 mathematics from the first activity. So now we will solve number 2 mathematics from the first activity. The question is given that universal set U equals x such that x is greater than or equal to 1, less than or equal to 20, and x belongs to positive set. Express the following sets in roster method. Set capital A equals x such that x is a multiple of 2. Set capital B equals x such that x is a multiple of 5. Set capital C equals x such that x is a multiple of 10. In the light of your work, ascertain the true or false of each of the statements. These statements are C is subset of A, B is subset of A, and C is subset of B. Here in the question you can see universal set U contains the elements which are actually positive integers, because we know capital Z refers the set of all integers which are positive and negative whole numbers. But in this question, universal set U contains the numbers which are actually only positive integers, and the range of these elements is 1 to 20. According to this universal set, we have to determine the elements of subset A, B, and C in roster method. Subset A contains the numbers from 1 to 20, and these numbers are divisible by 2, such as 2, 4, 6, 8, 10, 12, etc. Again, subset B contains the numbers from 1 to 20 which are divisible by 5, such as 5, 10, 15, etc. And subset C contains the numbers from 1 to 20 which are divisible by 10, such as 10, 20, etc. After expressing the elements of the subsets in roster method, we have to ascertain the true or false of each of the statements which has been given in this question. Solution. In roster method, universal set U will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Because these 20 elements are positive integers and they are greater than or equal to 1 and less than or equal to 20. According to the question in roster method, the elements of subset A will be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Because these elements are divisible by number 2 and the range of these elements is from 1 to 20. After that, according to the question in roster method, the elements of subset B will be 5, 10, 15, 20 because these elements are divisible by number 5 and set B is a subset of universal set U. After that, according to the universal set U in roster method, the elements of set C will be 10, 20 because these elements are divisible by number 10 and set C is also a subset of universal set U. So these were the expressions of subsets A, B and C in roster method. Now we will ascertain the true or false of given statements in the question. We will ascertain the true or false according to the universal set U, and we know the elements of universal set U is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That refers universal set U contains the natural numbers from 1 to 20. And we will ascertain the true or false of these given statements according to the universal set U. We know the elements of universal set U are 1 to 20, which are natural numbers. First statement is C is subset of set A. As we know, subset C contains the numbers 10, 20 and set A contains the elements 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Here we can see all the elements of subset C are present in the elements of set A. So we can say C is subset of A is a true statement. Second statement is set B is subset of set A. According to our solution, we know the elements of set B is 5, 10, 15, 20, where set A contains the elements 1 to 20, which are multiples of number 2. Here you all can see 5 and 15, these two elements of set B are not present in the set A. So we can say set B is not subset of set A. So set B is subset of set A is totally false statement. After that, third statement is set C is subset of set B. As we know, set C contains the elements 10 and 20 and set B has the elements 5, 10, 15, 20. So you all can see all the elements of set C are present in set B. So we can say set C is a subset of set B is totally a true statement. Now we will solve the last mathematics from the first activity of the chapter sets and functions. Number 3 question: if set capital A equals small a, b, c, d, e, then find power of A. To solve this question, at first we will remind the definition of power set. Gathering all types of subsets of a definite set is known as power set of this definite set. Here, to determine the power set of set capital A, we have to write down all possible subsets of set capital A together in the set power of A. According to the question, we know set capital A equals small a, b, c, d, e. So, power of A will be 5, A, B, C, D, E, A, B, A, C, A, D, A, E, B, C, B, D, B, E, C, D, C, E, A, B, C, A, B, D, A, B, E, A, C, D, A, C, E, A, D, E, B, C, D, E, D, E, B, C, E, C, D, E, A, B, C, D, A, B, D, E, A, C, D, E, B, C, D, E, A, B, C, D, A, B, C, D, E. So, these all elements are actually the components of power set of set capital A. These 31 elements togetherly known as power set of set capital A. Now we will practice some mathematics as like as the maths of first activity. Maths for practice. First question: given that universal set capital U equals 1, 9, 25, 49, 81, 121, 169, 225, 289, 361. Set A equals 121, 169, 225, 289, 369. And set B equals 8, 27, 64, 125. Express the above sets in rule method. Here you all can see the universal set U with two more another sets have been expressed in roster method in this question. According to the elements of these three sets, we have to determine the building method of these three sets. Since we know rule method is actually the building method of any set. Solution: according to the question in rule method, set U, universal set U will be x such that x is an odd number and root of x is less than 20. Because if we look carefully to the components of universal set U, we will see each and every element of universal set U is actually square value of numbers from 1 to 19. And each number is an odd number, such as 1 square equals 1, 7 square equals 49, 13 square equals 169, 19 square equals 361. Since the square value of 20 or 21 is absent in the components of universal set U, so we can express the universal set U as x such that x is an odd number and root of x is less than 20 in rule method. According to the question in rule method, set A will be x such that x is greater than or equal to 11 square, less than or equal to 19 square, and x belongs to odd numbers. Because if we look carefully to the components of set A, we will see all the elements of set A is actually odd numbers, and these numbers are the square values of numbers 11 to 19, such as square value of 11 is 121, which is the first component of set A. Similarly, square value of 19 is 361, which is square value of 19. Here you will see the square value of 20, that is 400, is absent in the set A. But the square value of 20, that is 400, is absent in the set A. So we can say in rule method the expression of set A will be x such that x is greater than or equal to 11 square, less than or equal to 19 square, and x belongs to odd numbers. After that, according to the question in rule method, set B will be x such that x belongs to natural numbers and root cube of x is greater than 1, less than 6. Since the elements of set B is 8, 27, 64, 125, so here you all can see in the elements of set B there remain both types of odd numbers and even numbers. So we can say the elements of set B are actually natural numbers. Therefore, all the elements of set B are the cube value of numbers 2 to 5. As we know, 2 cube equals 8, 3 cube equals 27, 4 cube equals 64, 5 cube equals 125, which are present in the set B. But the cube value of 1, that is 1, or cube value of 6, that is 216, are not present in the set B. So in rule method, we can express set B as x such that x belongs to natural numbers and root cube of x is greater than 1, less than 6. Number 2, now we will prove two statements that are given in the question 2. These statements are set A is subset of universal set U and set B is not subset of universal set U. We have to prove these two statements according to the question 1, where we got the universal set U with two subsets A and B in roster method. So to solve the first statement, that is set A is subset of universal set U, we have to write down all the elements of universal set U and subset A in roster method. According to our question, we know universal set U contains the numbers 1, 9, 25, 49, 81, 121, 169, 225, 289, 361. And set A contains the numbers 121, 169, 225, 289, 361. Since all the elements of set A are present in the universal set U and there have even no one number of set A which is absent in the universal set U, so we can say it easily, set A is the subset of universal set U. Second statement is set B is not subset of universal set U. According to our question, we know universal set U contains the odd numbers which are actually the square values of numbers 1 to 19. And set B contains the numbers 8, 27, 64, 125, which are cube values of number 2, 3, 4, 5. Here you all can see all the elements of set B are absent in the universal set U. Universal set U does not contain even any number of set B. So we can say it easily, set B is not subset of universal set U. So our two statements are proved. Number 3, the question is, express the following sets in roster method. Set A equals x such that x belongs to even numbers and 5x is less than or equal to 100. Set B equals x such that x belongs to integers and twice x is greater than minus 10 less than 20. And set C equals x such that x is a multiple of 12 and x is greater than or equal to 40 less than or equal to 84. So to solve this question, we have to write down all the elements of sets A, B and C in roster method. According to our question, we know set A contains the even numbers, and multiplying these even numbers, we have to take the numbers which are less than or equal to 100. By following this condition, we will get the numbers of set A as 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Because by multiplying 2 with 5, we will get the number 10 which is less than 100. By multiplying 14 with 5, we will get the number 70 which is again less than 100. But by multiplying 21 with 5, we will get the number 105 which does not match the condition of set A. So in rule method, the expression of set A will be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. After that, according to the question, set B contains the numbers which are integers, and by multiplying these integers with 2, we have to take the numbers which are greater than minus 10 and less than 20. According to this condition, the elements of set B will be minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because by multiplying minus 4 with 2, we will get the number minus 8 which is greater than minus 10 and less than 20. Again, by multiplying 0 with 2, we will get the number 0 which is again greater than minus 10 but less than 20. By multiplying 8 with 2, we will get the number 16 which is again greater than minus 10 but less than 20. But by multiplying 21 with 2, we will get the number 42 which is greater than 20. So the elements of set B will be minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. According to the question, set C contains the numbers which are multiple of number 12, and these numbers have to be greater than 40 and less than 84. By following this condition, we will get the elements of set C as 48, 60, 72, 84. Because 36 is also a multiple of number 12, but 36 is less than 48 and 84. But 48 or 72 or 84, which are multiples of number 12, they match the condition of being greater than 40 and less than or equal to 84. Now we will know a little about Venn diagram. In my next video of higher mathematics, I will try to discuss elaborately about Venn diagram with some mathematical solution of Venn diagram. So students, what is Venn diagram? Venn diagram is an illustration or a geometrical figure which is usually used to represent the differences and similarities among two or more sets of items. Venn diagram is popularized by John Venn in 1880s. Usually in a Venn diagram, you will see a rectangular shape which is used to represent the universal set U. And inside this rectangle shape, you will find two or more overlapped circles which is usually used to represent the similarities and differences between sets. For example, universal set U equals x such that x belongs to whole numbers and 10x is less than 150. Two more subsets A equals x such that x is a multiple of number 3 and x is less than or equal to 50. And set B equals x such that x is an even number between 2 to 12. In roster method, universal set U equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15. Because multiplying these numbers with 10, we got result less than 150. Set A equals 3, 6, 9, 12, 15 because these numbers are multiple of number 3 and they are less than or equal to 50. Set B equals 2, 4, 6, 8, 10, 12 because these numbers are even numbers between 2 to 12. Here in this Venn diagram, you all can see a rectangle shape is representing universal set U and 0 to 15 all whole numbers are present in this rectangle shape. Left circle is representing the set A which contains the numbers 3, 6, 9, 12, 15 which are actually multiples of number 2. And right circle is representing the even numbers from 2 to 12. So this is the figure of Venn diagram. In my today's video, I cannot discuss more about Venn diagram, but my Venn diagram slides are ready for more discussion. So in my next video of Higher Mathematics Bangla version and note form, I will try to give you more clear idea about Venn diagram. See you again in my next video. Remain with me and stay safe at your home. Khuda Hafiz.